Good day, everyone. Welcome back to RE class. I remain Engineer Shegun, and today we'll be discussing motion due to free fall, which is the same as motion under gravity. And we can categorize them into two, which is vertical motion under gravity and then projectile motion. Now, let's now talk about vertical motion under gravity. Still on vertical motion under gravity. Imagine you have a ball and you throw the ball vertically upward. So this is the ground level and that ball is going vertically upward. You would agree with me that from common day experience, as this ball is going vertically upward, it is slowing down with time, which means it is decelerating under gravity. So it will move vertically upward for some time, and it will get to a particular height where it cannot exceed that height. That height is called the maximum height. When it gets there, it will rest momentarily, which means it will rest for a very short time. Then from there, it will start to fall back to the ground. As it is falling back to the ground, it will be accelerating faster and it will be accelerating, which means it will be moving faster and faster as it's falling down. Then just before striking the ground, the velocity will be the same as this velocity it left the ground. Then it strikes the ground. Another scenario I would like you to consider is this. Imagine the top of a building. You have a ball, an object, or generally a body, and you let it fall from that height. Note, you let it fall, you release it, you did not throw it down, you just release it from a certain height, or you let it fall. If it falls, it will be moving faster and faster and faster and faster, then it will strike the ground. These are the two common kind of questions that they can ask in JAMB. In this category, we can say that whenever a body is moving upward, it is decelerating under gravity. And whenever a body is moving down, it is accelerating under gravity. So we now have a constant for it, which is G. G can be G is acceleration due to gravity. Don't say G is gravity, because gravity is a force. G is just acceleration due to gravity. And it has a constant value, which is 10 meters per second squared. Sometimes they can say G is 9.8 meters per second squared. If it is not given to you in the question, always assume it to be 10 meters per second squared. But if they give you as 9.8 meters per second squared, then you should use 9.8. You agree with me that 10 meters per second squared is an approximate value of 9.8 meters per second squared. That being said, the next thing I would like us to talk about are the equation of vertical motion and how we will use them. Still on vertical motion under gravity, we are going to be looking at the equation of vertical motion, and these are the equation. Equation 1, we have V is equals to U plus or minus GT. Equation 2, we have H is equals to UT plus or minus half GT squared. And equation 3, we have V squared is equals to U squared plus or minus 2GH. Now, so how do we use this equation? Before I talk about how we can use this equation, I want you to know that these equations are not entirely new equations. It is similar to the equation, to a linear equation which we have previously looked at. It is just that we are changing some of the letters. If you recall, in the equation of linear motion which we previously looked at, in equation 1, we had V is equals to U plus or minus AT. But here, we are now having GT. Why is there G? A and G, they both means acceleration or deceleration depending on the case. However, A was just normal acceleration. But this is a special type of acceleration, the one that is caused by gravity. That is why we have decided to change it from A to G. So if you have that in your mind, you know that this is really not new. Because that one was A acceleration. This is G acceleration, but it's not the one due to gravity. That's why we have G here. In the previous equation, recall that we had S where I told you that S is distance or displacement. Here, we are replacing that distance with H. Distance, you know what it means. This measure of separation between 2 points. Height is also the measure of separation between 2 points. But since we are looking at a vertical distance, we decide to use H instead of still using S. It is not so different from that. UT plus or minus half GT squared. And then we have V squared is equals to U squared plus or minus 2GH. The plus or the minus still remain how we were using them before. Previously, you know, I told you that if a body is accelerating, we use plus, and if it's decelerating, we use minus. That is still true here, but you should understand this, that if a body is thrown vertically upwards, if a body is moving upwards, then it is decelerating. So we'll use minus for any body that is going up, any object that is going up. Some will say because it's moving against gravity, so use minus. Yeah, that is an easy way of remembering it. But basically, if it's going up, it's decelerating. That's why we're always using minus. If it's falling down, it is accelerating, so we'll use plus. The same for this and the same for this. Now, I want you to understand that in all of this motion, we are considering that this whole thing is happening in the absence of air resistance. So that's why they always say neglecting air resistance. And I should add this. All objects, irrespective of their masses, if you check the equations of motion, mass is not there. Because all objects, irrespective of the masses, will fall from the same height with the same time. Meaning that if this were to be a feather, for example, and this were to be a stone, if this was to be a perfect vacuum, and I let both of them fall, from this height, both of them will get to the ground at the same time, if we were to neglect air resistance. I know this is not our common day experience because of air resistance, but if we were to conduct that experiment in the perfect vacuum, that's what we are going to experience. So note that because this question has been asked before, all objects, irrespective of their masses, will fall to the ground from the same height at the same time. Now that this is said, let us now look at questions that have been asked from here. Still on vertical motion under gravity. This is question number 1. Now, just like we previously said about our equations of vertical motion, let me add this tip so we can be able to solve this question with it. And it is, note that whenever a body is released from a certain height above the ground, if they say it is released or it falls from a certain height above the ground, then u will be equal to 0. U meaning our initial velocity. However, if you throw it vertically upward and maximum height is mentioned, at maximum height, the final velocity is equal to 0. Now that we have that concept, let's look at the question. An orange is dropped from a height at 100 meters above the ground level. We set out our parameters, which means that height is equal to 100 meters above the ground level. It was dropped, it was released. Just like I said, if it is released or it is dropped, u will be equal to 0 meters per second. Calculate the velocity of the orange just before it hits the ground. This velocity they are asking us for is the final velocity, v. We are looking for final velocity just before it's in the ground. Next question we are going to ask is, before even asking ourselves that question, we know g was given to us in the question, and they told us that g is equal to 10 meters per second squared. They were being specific. Supposing this was not given to you, you should also know that g is equal to 10 meters per second squared. But now it has been given to you. Most times, we just assume that g is equal to 10 meters per second squared. But like I said earlier, there are some few questions whereby they will not tell you to use g as 9.8. So if you are reading the question, before you go straight to solving, you should read the question to the end and see what they are asking you to use as g. You use what they ask. It's either it will be 10 meters per second squared or it will be 9.8 meters per second squared. But most of the time, it's 10 meters per second squared. So we know g is equal to 10 meters per second squared. So let's ask ourselves the question, which of those equations are we going to use? Which of those 3 equations are we going to use? Are we going to use the first one? Of course, it cannot be the first one. It cannot be the first one because there's time in that one and there was no time being mentioned here. I cannot use the second one because, of course, there's also time there. Therefore, the choice I'm going to make is to use the what? The third equation, which is v squared is equals to u squared plus 2gh. Notice now I'm strictly using plus. Why? Because it is falling down. It is accelerating, so I'm going to use plus. I want to find v. So doing this, I'm going to say v squared is equals to, u is already equals to 0, so I'll say 0 squared plus 2 times g, which is 10, times the height, which is 100. This is going to be v squared is equals to 0 squared is 0, which of course is 0 times 0, so it's 0, plus everything here will give me 2000. Now I'm now saying v squared is equal to 2000 because 0 plus 2000 is 2000. Therefore, I will say v is now equals to the square root of 2000. If I take the square root of 2000, I'm going to have the square root of 2000 to be equal to 44.721. 44.721 meters per second square. This is the velocity of striking the ground. So let's consider question number 2. Still on vertical motion under gravity. This is question number 2. And the question goes like this. A body is projected vertically upward from the ground level with an initial velocity of 20 meters per second. Calculate Roman figure 1, maximum height attained. Roman figure 2, time to attain maximum height. And Roman figure 3, time of flight. So we're going to treat this individual question one after the other. Maximum height attained. In order to answer or to get the maximum height attained, the question is, what equation are we going to use? And to get to know what equation to use, we need to set out our parameters. Whenever a body is thrown vertically upward, you remember I told you that at maximum height, final velocity is equals to 0. But if it is thrown upward, it will always have an initial velocity because that's why it's going up. But if it was to be dropped, then u is equals to 0. Remember all of those stuff. I said that. Anyways, so here u is equals to 20 meters per second. Then, of course, g is 10 meters per second squared. And we are being asked to find maximum height attained, h. We are looking for h. If you are being asked to find maximum height, that means maximum height is mentioned there. Remember, at maximum height, the final velocity is equals to 0. So now we are looking for h. The question is, which of this equation are we going to use? I think you are guessing right now. We are going to use the third equation, which is v squared is equals to u squared. But this time we are going to use minus. Why are we using minus? Because it's going up, moving against gravity. Minus. As it's going up, it's also decelerating. So minus 2gh. I am looking for h. Let's put in our parameters. Now, if we put in our parameters, we are going to have what? v squared, v is equals to 0, so I have 0. 20 squared minus 2 times 10, h. This is going to be 0 is equal to 20 squared is 400 minus 2 times 2 times 10h will give us 20h. From here, I will take 20h over to the other side. And you know that once it crosses the equality sign, this minus will change to plus. So this is now 20h. Me writing 20h here is same thing as saying plus 20h, which is now equals to 400. Now, I would have to divide both sides by 20h. In order by 20, I will have to divide both sides by 20 in order to make h subject of formula. If I do that, I'm going to have h is equals to 400 divided by 20. Now, this 0 cancels this 0. 2 goes into 40. That will give me 20 meters. So the height is 20 meters. That's for Roman figure 1. Now, let's take Roman figure 2. Roman figure 2 is time to attain maximum height. How are we going to solve for the time to take to attain maximum height? Let's just keep this aside first. Let's set out our parameters again for that Roman figure 2. So I'm going to wipe down this part and put Roman figure 2 here. I hope you are following. Now, from there, I have in my Roman figure 2, same thing. U was given to us, which is 20 meters per second. Of course, G was given to us, which is 10 meters per second squared. And final velocity, because maximum height was mentioned, is equals to 0. At maximum height, final velocity is equals to 0. Now, I'm looking for time. The next question I'll ask myself is, which equation is suitable for me to be able to find time? Which one will be suitable for me? What will be suitable will be the first equation, equation number 1, which is V is equals to U minus GT. Note, I'm using minus here. Why? Because it's going up, decelerating, minus. I think it was falling down, plus. So, V is already equals to 0. They give us initial velocity, which is 20 minus G, which is 10 T. Take this guy over to this side. If I do that, I'm going to have 10T is equals to 20. Now, I'm going to divide both sides by 10 to make T subject of formula. If I do that, then I will have T to be equal to 20 divided by 10. 0 will cancel out 0. Then I'm going to have 2 seconds as the time. So time taken to get to maximum height is 2 seconds. Let's answer Roman figure 3, time of flight. Now, this is actually interesting. I need to explain this in a way that you grasp the concept. For Roman figure 3, we are asked to find the time of flight. What do they mean? If you have an idea of the entire motion, a tree is vertically upward like this. It was going up, going up, going up. It attained a maximum height. It rests momentarily. That's why final velocity is equal to 0. Then starts to fall down to the ground. And then it strikes the ground. You should note that the time it took it to move from here to here, let's call it small letter t, would also be the same time it would take it to move from here back to the ground level, which is also t. From here to here and from here to here are the same. When they say time of flight, they are talking about the total time spent in the air. Sometimes they may not even mention time of flight. They will say how long will it take for it to return back to the ground level, which is the same thing as time of flight, which is the total time it will take to return back. Now, so I can say therefore that let's use a different letter to represent time of flight. Now that we have realized and now that we know that time of flight, capital letter T, and this time are different. This is just the time to get to this maximum height. Time of flight with capital letter T is simply what? 2 is simply small letter t plus small letter t. From here to here and from here to here. T plus t is equal to 2t. So it simply means now that whenever you are being asked to find time of flight, first calculate the time it will take to get to maximum height. Then multiply that time by 2. We have already solved for the time it will take to get to maximum height, which is 2 seconds. Therefore, the time of flight in that question, we will now be using this stuff is t is equals to 2t, t is equals to 2 times 2, which is equals to 4 seconds. That is it. Now, let me quickly add this to everything I have said. These questions, or questions that you can see from this place, are extremely simple. Know how to pick your equation and remember everything I have said about them. So sometimes they can ask you to find any of those parameters. It's just a matter of making them subject of formula. Recall, V is equals to U plus or minus GT. H is equals to UT plus or minus half GT squared. And V squared is equals to U squared plus or minus 2GH. In our next class, we are going to now look at projectile motion.